Everyone, welcome back. It's been a while since we've all been in here together, but I think we have a really good reason for that today. We're going to start a unit on an entirely new programming language. So, does anyone have any idea what that programming language might be called? Tia. Objective-C, awesome. Now, Tia, staying with you, what do you think Objective-C lets us do? Call a friend.
Stay objective.
Okay, Objective-C. Objective-C. Let's stay objective. What do you mean by that? Besides using one of the context words in there. Okay, cool. What can we use Objective-C for? What do y'all think? Why are we bringing this up in 6.1 iOS Days class?
Foundation for Swift, right? So probably all those work with.
So I'm going to leave that as an open question. Is it the foundation? Sort of. In some ways it is, definitely. But in other ways, Swift is entirely its own thing. Carrie?
Is it like because it's familiar and we use like Objective-C functions when we make buttons?
Yeah. We make buttons. What framework are you working with when you use those buttons and stuff? At the top of the file, it'll say something just like this. What are we importing on line 1? Just read it. On line 1, just read it.
Oh, import.
Importing what?
Foundation. Is that what it is?
Well, which one do we use to make those buttons? Yeah, perfect. So we use its functions when we make buttons. So that might mean it interacts well with UIKit. Might be because UIKit's originally written in Objective-C. That's weird. Why do you think we are teaching it to you? Okay, why learn it? Really, number one reason to pay attention. Looks good on a resume. Kimball.
Maybe the built-in functions are not
That's interesting, yeah. Not be as powerful as some from Objective-C. What else do we think? I have like a less theoretical, less interesting reason. And that is that Swift came out in 2013, and there were iOS apps before that. Those apps were all written in Objective-C. So Swift is pretty new. And I think the iPhone came out in like 2006 or 7. I don't know. I'm only an iOS instructor. An iPhone came out a bunch of years before that. So apps were originally written in Objective-C. So Swift didn't exist. We only had this thing called Objective-C. And so we had to use it. There was nothing else to use. It was just Swift or nothing else. Swift is pretty miraculous because we don't have to deal with a lot of ugly words and stuff, but this thing came out way before Swift, this hunk of junk called Objective-C. And it let us do some really important things, like use the entire UIKit framework. Like let us use Foundation, which we'll get into more on Thursday, why Foundation actually exists. It lets us do a ton of different things. Here's a really important thing that it also lets us do, is, again, speaking less excitingly, more practically, it lets us go look at source code for libraries that have been around forever. So this here is Firebase. Has anyone ever used Firebase? Me too. It's pretty good. Lets you do a whole bunch of things, right? So you can actually use messages, you can create cloud functions, you can store stuff in collections, you can do some really fun stuff. You can create Crashlytics, which used to be its own thing. This is an incredibly robust library of frameworks. And if we go look at Firestore, we go look at Core, we go look at the source code, and we go look at something like auth. You see that none of these files, if we look at the extension, this is a bad example, but none of these files are written in Swift. None of them are a .swift file. So it's fun because Firebase Firestore is actually written in C++, so let's look away from that. But most source code that we'll see in Firebase is written in Objective-C. Maybe a better example might be Firebase Storage, sources. Look at all this navigation we're doing into Firebase. So we've got these series of files. I've got firststorage.m, I've got firststoragecomponent.h, I've got firststoragecomponent.m. I've got all these files that end in m and h. So this is a completely different way of doing things than we're used to. We are used to just building everything in Swift, letting that Swift file do some stuff for us. But we're going to have a completely different setup with Objective-C, because Objective-C is built on top of the C language. And what Objective-C is built for it's built to add some object orientation to the C language. The C language is an old language where languages A and B didn't really work, so they came out with C, and they were like, this is a pretty good basis. And we're going to build a ton of stuff with this. It lets you manage memory, lets you build entire programs, but there was some stuff missing, so people created such things as C++, C#, Objective-C, and now this is what we've got. We've got Objective-C, which is built on top of it specifically or for the main reason, or in its most useful form, to allow us to use objects. What's an object? Yeah. So in Swift, we've created objects using classes, structs. What's another kind of object we create? Yeah, I love my enums. I'm glad. So we've used those to create objects. And those are things that have some properties. And do some stuff, right?
There's a Objective-C object-oriented language.
Oh yeah. Well, this is actually a really important point that Levi brings up. Objective-C is an object-oriented language. So in Swift, we have objects, but it's actually geared towards something a little different. What's the way that we ensure that we have similar behavior and properties across a bunch of objects and classes? Phoenix. Yep. So Swift's paradigm, I'm going to just say that the way we're meant to use it is protocol-oriented programming. This means we can have objects, but the way we tie everything together in our programs is to create protocols that share properties and behavior. This is an important distinction because Objective-C is not going to work the same way. So this is kind of the interview part of the lesson where we talk about the important things that you should at least be able to respond back to an interviewer. Are you ready? Okay. So Objective-C is meant for object-oriented programming. Does anyone by Nook or by Crook come across what are called the 4 pillars of object-oriented programming? Yeah. So you'll often see object-oriented programming abbreviated as OOP. One of those pillars is encapsulation. We've used encapsulation plenty. Actually, Liana has yelled at me for not just giving her the encapsulation of something like a persistence helper. And that's okay. We sorted it out. But what do you think encapsulation means? We've seen it in those persistence helpers and our network managers and our image helpers, stuff like that. What's kind of the common theme there? So, not a singleton, but why have we used, like think of the purpose of those managers and stuff. Why have we used those things? We've used them to, yeah.
Getting the data and bringing it to what we want to do.
Yeah, I think we're getting there. Adam?
It keeps our data in constant state from outside interface being misused. That's the purpose of encapsulation.
That's just off the top of your head?
Yeah.
Okay, can you say that again?
It keeps the data in functional state from outside interference and misuse.
Yeah. So we use encapsulation, and there's going to be a related term called abstraction. That's another pillar. We use encapsulation to just use those things in the way that they're supposed to. And that means that we implement our functions, and we implement the way that we use data so that it can only be used in that specific way. We encapsulate the way it should work. Nima. Okay. Tia. I am. This little boxy guy right up there. So that is one pillar of object-oriented programming, encapsulation. Eric M. Can you give me another pillar of object-oriented programming? Do you want to pass it to Kimball? Inheritance. Okay, cool. Inheritance. Does anyone have a good example? Nope. Does anyone have a decent definition for what inheritance is? Jack, can I ask you what inheritance is? What does it mean to you?
Getting all the properties of your ancestors.
Getting all the properties of your ancestors. Amazing. Like houses and stuff like that, or something specific to programming.
System programming.
Okay. So, what is an ancestor?
It's your classic.
Cool. We actually, yeah. We'll actually like make a quick distinction here. Is a class that is the parent of your class, whether it's a superclass or a root class. So for example, whenever you start a new storyboard project in Xcode, you're immediately given this new class called ViewController, which inherits from the class UIViewController. Seen that before a few times. And what does that give us for this class called ViewController? Without you writing any code, what do you have access to? Sunny? Yeah, can you give me some examples? So there's the default view of that view controller. That's an important property. That's what we put everything into. What else is there? What else do we inherit, Albert? So we don't inherit the extensions, but even when we just open a new storyboard project, what do we see in that view controller class? Like just by default without you writing any code. What's something you see in there? You did load. Cool. Other lifecycle functions. So this is classic inheritance. You get all of the properties and the methods of your superclass. That is the way that Objective-C is oriented. So instead of wide protocol usage, we actually tend to use more of inheritance. We say, here is some big category of object. It's got a subclass that has all of its behaviors and also some of its own. That subclass might inherit into a sub-subclass, and that is very different than protocols in what specific way? Tia.
Have to use everything within inheritance, whereas the protocol.
So that is true, yeah. So we don't have to use everything that's inherited, but we do have the ability to do that in protocols, right? There's something, you can set it optional to have a property or a function. There's something super important here, though. Sunny?
Protocol doesn't hold any data information or blueprint.
Yep. So protocols are blueprints, which means there's no implementation unless you extend them, set up some, I don't know, implementation in a class or struct, whereas with classes, sorry, with inheritance, we actually have properties and functions available to us. That's super important. Protocols don't do anything until you tell them what to do. When you inherit, you can do stuff immediately. You can do whatever the superclass has allowed you to do. So you've got properties and you've got functions. Cool so far? All right. What's another pillar if you had to guess at it or you've Googled it? Abstraction. What do we think abstraction means? Yeah, that's really good. I like that. Take something complex, make it simple. What are some other thoughts? Yeah? Make some things private for, I might have missed the end of that, sorry.
That's some functionality is available. Kind of like how you make things private in our households, right? They can't be manipulated elsewhere.
Yeah. I'd combine these and say, giving our code a specific purpose for other people. And so, in Objective-C, we see these two different file types, a .h and a .m. And some of them are named the same thing. Let's see what's going on in there. So I'm going to look at this FIR store component.m file and this FIR store, I opened the wrong one, sorry, store component.h file. So here's the .h file. Blah, blah, blah. It's got something interesting going on there. Ooh, it's even got a protocol. That's so nice. It's got some classes in it. It's got this thing called an interface. Looking within, we're going to talk about all this syntax, don't worry. But looking within this interface until that end line, what does this kind of look like? Albert. I'm sorry? A little bit. Let's read through these comments. So this is a property. So this is like a variable or something on some class called fire storage component. This is a default method. This is looks like an init. And that's all within this thing, interface to end. So it doesn't quite look like a class. We'll see something that looks more similar to that in a bit. It kind of looks like a protocol. Kind of. So in these header files, that's the .h. Header file contains the interface. And that's what a user can use this for. So that .h kind of looks like a protocol because we're telling users, hey, you can use this property, you can use this method, and you can supposedly use this init, but they say it's unavailable. So this must be something that has a deprecated portion, or this is meant to be private. This interface file is telling you what you can and cannot use from some underlying code. It is not itself a protocol. It's just telling you the blueprint for what you can use. Because in the .m file, we're going to see implementation. And the implementation is the actual code that can be used. So in this same thing that we had an interface to, it says how this should be initted. It says, let's look at that other name. What's it called? Storage for bucket. Storage for bucket. It's the actual implementation of that function that we just saw up there. And let's see what else we got. We got a Fire app, F-I-R-A-P-P. So that's a property available all throughout. We'll load one, we'll init one, we'll actually import some stuff. And if you notice, look at these imports. What types of files are those? Yep. So all of, sorry?
What does the H stand for?
Header. Yeah,
What does the M stand for?
I don't know. What? The meat of the file, sure. But if you look at our imports, that interface is all that we use to use the code that's implemented in the .m file. So these header files are some other code written somewhere else, and we just need to say, okay, I want to take the interface for this thing called FIR app internal. I don't need to actually say, also import the implementation of that, and Objective-C is going to go and provide you with whatever is available in that interface. Kimball, and then Sunny. Yeah, it just is, think of this as like a configuration that lets you use Objective-C. In your .h is what code you will want to make available to other parts of your program. And in your .m is the actual implementation, whether that's public or private. Sunny.
So is this Objective-C?
This is Objective-C.
And then you mentioned that in the header files, we have blueprints, but they're not protocols, and is that because Objective-C doesn't deal with protocols officially as the type of certified?
So it does have protocols, but I just wanted to show you like this interface itself is you telling other, it is like a protocol with implementation. This interface portion, what's imported in .h files is the interface of some underlying code. So in my .h file, I will put all the code that I need for someone else to use my thing called FIR storage component. That code and how it's actually implemented is going to be in the implementation section of my code. And so this itself is not a protocol, but the way you're going to arrange your code in your interface is as if you had a protocol that then has implementation of that code in a file that is named the same exact thing.
It's only used once in the implementation.
What is only used once, sorry?
That blueprint is implemented once in the .m file.
Yes. Think of this implementation as just you writing a list of things in your code that other parts of the program can use.
Is this the kind of Objective-C we'll be writing in the implementation?
Not this specific because this is a little older, but in the pattern of having an interface and having an implementation, that is standard. That's how we'll do it.
So I want to say that there is always a .h file and a .m file associated with it.
That is such a good thought. Can you say that again?
Does that mean that a .h file always has a .m file associated?
A .h file always has a .m file associated with it. That is correct. The inverse relationship is not true. You can have implementation without interface because, let's look again, because if you don't need to export that code anywhere else, if you don't need to import it in some other file, you don't need an interface for anything else to read. So if you want to have implementation for your interface, you need a .m file for that .h file, but the reverse is not true. We're actually going to work with just the .m file today. So .m file is going to contain implementation for that interface's code, both what will be available, to import via the interface and any private functionality. So this is kind of like what we do in a typical .swift file, except later on, you're going to have a .h file that says, actually, these are the parts of my class you can use. So header files are the way communicate between parts of the program. If anyone can find a good name for a .m file, those files are the actual code to execute. I'm going to put that in quotes. Tia. Don't know. Main. So we have main.main. Okay. We're going to talk about next week about what these @ signs mean. They might look pretty familiar because we've been using them all over when we need to import some Objective-C runtime stuff into our Swift code. All right. There is briefly one more pillar of object-oriented programming.
Sorry, stupid
Yeah.
question.
Yeah.
A little lost, in terms of the header file versus the main file.
Mhm.
In the sense that, like, when you're on the other page, and it is the, can you put that through? Yeah, the add interface to end,
Mhm.
is that stuff, like, everything in between things that we're building on its own, or is that kind of like auto-populated and?
None of this is going to be auto-populated. So if you look, the .h file has the interface and like a protocol that might be available for others to use. There might also be interface files in your main file, your .m file, and those are going to be used to like continue to, or for your implementation here. So this right here, this, what do you want to call it? This keyword that says, let's start our implementation here, also needs to interface with something called Fire Storage Component and Fire Storage. And so that stuff is in here. We're going to worry about making more complex programs like that in like the coming weeks. But for now, the big difference to know is in the header file, there's an interface. In the .m file, there's an implementation for that interface. And then the interface is what's imported all around the rest of your program. Sunny?
The process of separating the header and the main code abstraction, is that
So the actual abstraction is having an interface here. So you've written all this code in your implementation, and then you abstract it into what someone else can use in your interface. And also, if we're talking about this on a higher level, abstraction itself is saying, I've got this class that, for example, lets you save something into Firebase storage. You've abstracted a whole bunch of code from connecting to Firebase, finding buckets, converting images to data, all that stuff is already abstracting that behavior into a specific purpose. So the way we accomplish abstraction is through our interfaces, where we say, I've written a whole bunch of code, you can do stuff with it. You have a purpose for using my code, but you don't need the nitty-gritty.
Would you say that the way that you taught us to use MVC uses a lot of these principles?
Yes. But I say the way we've taught you to use MVC uses these principles. Yes. And that is specifically because we need objects in order to use protocols, right? Protocols don't do anything unless they apply to an object. So at the root of protocol-oriented programming, we're going to have objects. But we're going to share less behavior as a blueprint. Instead, we're going to use inheritance. So I think the biggest change we'll see is inheritance here. The last pillar, I'm just going to put it up here, polymorphism. Has anyone ever polymorphed? Did anyone ever watch no, what it's called? Animorphs. Animaniacs, Animorphs. Would being a polymorph apply here? No? Okay. Jason, if I asked you to give me just a quick thought about what polymorphism is.
It's derived from two Greek words, poly and morphs. The word poly. Polymorphism means many forms. A subclass can define its own unique behavior and still share the same functionalities or behavior of its parent/base class. A subclass can have their own behavior and share some of its behavior of adjacent class.
Okay. Thanks, Jason. Amazing. Say that again.
It means you can use a child in a different way than you use the parent.
Use a child in the same way you use the parent. We're talking about children and parents here. What do you think? What other principle is that applying to? Yeah, talking about inheritance. Oh, when have we seen this all the time?
Function overloading and function overriding. Well, overriding for inheritance.
Mm-hmm.
Overloading for this function implementation has the same functioning and different for
Yeah. So polymorphism means that we are going to use these same names and say that these are related functionalities, but we're actually going to use them in different ways. I know that's not great, but the two very concrete examples are overriding. So for example, you inherit a view did load, you override and write your own, and overloading, where we might init using no arguments, we might init using 6 arguments, we might init using 3 arguments, and those are all allowed in one type of object in Swift. What type of object is that? Yeah, we can overload, like think back, I don't know, July. We can write multiple, for example, init functions in one type of object. Yeah. So to support this overloading and this overriding, we're going to use classes mainly in Objective-C. Can we override functions in structs in Swift? We can mutate functions, yeah. So I'm going to say, why not structs? The arrows always copies, but let's think about the definition of a struct. What don't structs support in these 4 pillars of OOP? Yep. You can't inherit functions or properties in a struct, so we can't have an override at all. You can't override a function because your override is overriding the function of your superclass. It's not available. You can't have polymorphism.
It's just once a protocol, right?
Sorry?
You can use protocol on structs, right?
So we literally can't use the keyword override in a struct because there's no inheritance. There's nothing to override. So we don't have that kind of polymorphism. Wild, huh? What is, here's a 10,000 million, 4,000, I don't know numbers. What does that mean for us when we use memory in Objective-C? Classes. That can be true, it can be false. What does this, sorry? what do these four pillars and the fact that they almost always make us use classes mean for us when we use memory in classes, in Objective-C? Yeah, classes have memory leaks. Why do we have to look out for memory leaks? What do we know about classes? Yeah, classes are reference types. So almost everything we use is going to be a reference type. And then that means what?
If there's two things referring to each other, then it'll stay in memory.
Yeah.
So you have to let you know that those references so that
And also, I have some really bad news for you. We actually have to manage our memory to some degree. I'm so sorry. No. Manually. I guess reference count. I guess count our references. We don't actually have to keep a tally, but we are going to have to do some specific things to make sure that we get rid of stuff in memory. Tia.
With that last sentence, where you kind of, if I'm trying to translate that, like if you're working on, I don't know, the Fibonacci sequence and it gets too large, you're saying like we will have the ability to manipulate the memory for stuff like that, or like can you, I don't know, what would
Yeah.
it look like?
So here's a classic example. Let's say I've got var A. I'm going to just do this down here. Example, var A is equal to some class thing. Then if I say var B is equal to A, and then if I change A, it also changes B. So because we're always dealing with references, we have to be careful how we are changing those references, how we're allotting those references, how we are just communicating information between things in memory. All right. So we're going to have to manually manage our memory. I'm sorry. It's not that bad, I promise. All right. I want to put two buzzwords out there, and I would encourage you to look into them before Thursday. Yeah, I'll call it important vocab terms. One is a pointer. I hear a cry for help. Tell me about that cry for help. I just heard a cry for help. Do you want to explicate your feelings?
No, I think
Okay.
I think that multiplying everything.
Hated by some. Look into what a pointer is. I'll give you a hint. It is something about how Objective-C is going to let you put things in memory. Because you're going to have to explicitly tell it, yep.
pointer is a variable whose value is the address of another variable.
Ooh. So a pointer can be a variable to a place in memory. That's the value of another variable. That's a pain. That's okay though. We're going to work a lot with pointers on Thursday. It's really delightful. And here's another important vocab term for Objective-C. Message sending. This is going to be important for next week, but you should also look into it. Our objects in Objective-C, they don't actually have methods that we call. Instead, we say that they send messages to other objects. If it makes everyone feel better, the implementation is different than using a method in Swift, but hey, everyone just calls them methods in Objective-C. I promise you. Well, we should know that the actual way that functions work on objects is they are not methods that are called on an object. Instead, they send messages. This is almost purely memorization because it is not going to impact the way that we use these things, except in a few special cases. So when we say we're using a method for a certain object, what we're really doing is sending a message from that object to another object. Yay, vocabulary. Let's take a 6-minute break, and then we'll come back and write an Objective-C program. Hooray!